What if the Earth started shrinking by 1 centimeter every second? Let's suppose you're outside, enjoying a coffee, scrolling through your phone, and suddenly, without warning, the Earth begins to shrink. Not metaphorically, literally. The planet itself starts getting smaller by 1 centimeter every second. Sounds slow? It's not. 1 centimeter per second means over half a meter per minute, more than 30 meters per hour, and over 700 meters per day. That's like the entire Eiffel Tower just gone vertically every single day. Now, the first thing you'd notice is nothing, at least not for a while. A centimeter is really small, and Earth is really big. But soon enough, small inconveniences begin piling up. GPS satellites start reporting slightly off coordinates. The curvature of the Earth becomes just a little tighter. And buildings? Over time, they start to feel weirdly out of alignment. Not because they're moving, but because the ground beneath them is suddenly curving more than it used to. But let's rewind. What does it mean for the Earth to shrink? Are we talking about just the surface, the crust, or is the whole mass condensing in on itself? Because if it's the whole Earth, core and all, then we're in serious trouble. When the volume decreases but mass stays the same, the density goes up. And if you start making something the size of Earth denser and denser, at some point you stop having a planet and start having something else. To understand how bad things can get, we'll need to consult an old friend: gravity. The strength of gravity on the surface of a planet depends not only on its mass, but also on how far you are from its center. Shrinking Earth by 1 centimeter every second makes that distance shorter, which means over time, gravity gets stronger. Not by much at first. After a day of shrinking, gravity might increase by a fraction of a percent. You'd feel slightly heavier. Maybe your back hurts more than usual. Maybe your cat, who already hates you, starts sliding off the couch a little sooner than expected. But give it a few months, and it becomes noticeable. You're getting tired just walking upstairs. Your knees are begging for mercy. Airlines start canceling flights because fuel requirements are rising, thanks to the increasing pull of gravity. 6 months in, you've now lost over 125 kilometers of Earth's radius. That's not just a change in size, that's a gravitational red alert. Oceans start acting weird. Higher gravity means water flattens out more, so sea levels shift. Not everywhere, not uniformly, but enough to cause massive disruption to coastlines. Some harbors dry up while others flood. Boats capsize more easily. And let's not even talk about the whales. No one prepared them for this. Now, the atmosphere. Shrinking the planet compresses everything, including the air. As Earth contracts, the atmosphere is squeezed downward. Air pressure rises. You feel it in your lungs. Breathing becomes harder, not because of less oxygen, but because the denser air resists expansion. Airplanes struggle at high altitudes. Weather patterns start to spiral out of control. And don't even think about hiking Everest. It now feels like lifting weights with your face. By now, scientists are freaking out. The Earth has shrunk so much that its core temperature is skyrocketing. More pressure means more heat. Volcanoes that were dormant start acting twitchy. Earthquakes increase in frequency and severity. The crust groans and pops like a baked potato in a microwave. Yellowstone? Yeah, that's not a national park anymore. That's a national warning label. And we're not even into year 2 yet. By this point, gravity is increasing dramatically. Earth's surface is noticeably more compact. Buildings collapse not from earthquakes, but from their own weight. Your bones start aching. Birds stop flying. They just give up and walk. You can't sleep flat anymore without feeling like your organs are being vacuum sealed. Eventually, the shrinking hits a critical point. Earth becomes so dense, it starts curving light around it more than usual. Gravitational lensing, the thing we use to spot black holes, starts becoming visible from the ground. The horizon begins to warp ever so slightly. Sunsets last longer and look weirder. Stars twinkle oddly. Photographers love it. Physicists cry. If this continues, Earth will eventually collapse into a neutron star. That's the kind of thing that happens when matter is so tightly packed that electrons and protons merge into neutrons. A sugar cube-sized chunk of neutron star weighs more than Mount Everest. So, imagine your entire planet doing that. Now, you may ask, would we survive long enough to see Earth turn into a neutron star? No. You'd be dead long before that. Somewhere between gravity doubling and the atmosphere collapsing, life becomes impossible. Your internal organs get squished. The oceans crush everything beneath them. The air ignites. The electronics fail. Satellites spiral down and burn up like mosquitoes in a bug zapper. And then, silence. Earth shrinks past the point of no return and becomes a dark, super dense remnant floating in orbit around the sun. A cosmic marble, quiet, alone, radiating ghost heat into space. So maybe we should be grateful that our planet doesn't have a shrinking problem, because even a simple 1 centimeter per second can turn your cozy blue marble into a cosmic death trap. And next time you're walking up a hill and feel tired, just be glad gravity hasn't gotten worse, yet. Subscribe, guys.